This video is brought to you by Greater Commons. Greater learning, greater opportunities, greater life. Visit us.
All right, so we're going to look at cookies now, and that weird sort of matrix vision thing is my screen recording software. And I put together this README file here, and if you're just catching this on the internet, you can find all the code at GitHub. Goes to 11, baby. Go watch, just YouTube goes to 11. Rob Reiner, Spinal Tap, if you don't know what that means. And Golang Web Dev is the repo we're working in. We're looking at the cookies folder, which is right there. And you can also follow me on Twitter at Todd McLeod, baby. Right there. I promise I won't say baby all the time. But I do say it some of the time. Alright, so we're going to look at how to set a cookie. And to set a cookie, we have this first example here. This code's just all written so we could get through it quickly and look at it quickly. Oh, and the one thing I want to say is I have a README file. And let me, I'll push this up when we're done recording. But this README file talks about cookies and, you know, how they work. And, see, I have expires versus max age. Expires is deprecated, there's max age. And then there's this article on cookies because it gets a little confusing. Cookies get a little confusing with their attributes. And so domain and path are particularly confusing. We're going to do a little exploration here and do a little coding to see if we can figure some of that stuff out towards the end and in another video. But first, I just want to show, we've been looking at this in class, and I want to show it to you watching online. Godoc.org, NetHTTP, go to the index and look for cookie. And we have type cookie right here. There's set cookie, and then there's type cookie. And if you click on type cookie, it's a struct. And you can see it's a struct with these fields. Name, what's the name you're going to give to the cookie? What's the value? But then you have these other fields like path and domain. This gets a little confusing, but allows you to specify if the cookie is only, this is just my understanding, and I'd like to create some code to test it. But it lets you, and you can watch another video to figure out I was going to go into my backstory, but the path and domain allow you to specify where is the cookie valid, right? Is it only valid at, you know, mcleods.com/user/Todd and everything down beneath Todd? Is that cookie only good there? Or is that cookie valid for this user anywhere in the entire domain? Any path, right, in the domain? I could set path to specify where, or I could set domain to specify if it's the whole domain or just subdomains that the cookie's right good for. This is deprecated, expires, use max age, you set it in seconds, given in seconds right there. And secure means that you could only transmit the cookie on HTTPS. So is this review good for you all in the class? Sounds like I know what I'm talking about now that I'm making the video, right? We just did like 30 minutes of research together as a class reading about the difference between path and domain. That's why in another video we're going to be doing it. But secure means only HTTPS. That means your cookie can't be sniffed going over the wire, you know, and it's all encrypted. And it won't be transmitted if it's not encrypted. So that's always good to set to true. And HTTP only means your cookie can only be accessed via HTTP. JavaScript, client-side scripts cannot access the cookie, so that's good. These things here, I don't know. So if you go research it and figure it out, add a little note to this YouTube channel or send me a note on Twitter or something. Tell me what you discovered. Send me the link. Because, man, always operating on the edge of understanding. All right, so let's take a look at setting a cookie. And so here we have, you know, different routes where this route runs this code set. And we just do from package HTTP set cookie. And if we look at that, we had set cookie. I'm just wondering if it's close there. I thought it was, but we'll go back to the index. Wah, wah, wah. Right here, set cookie, right? And so set cookie takes a response writer and then a pointer to a cookie. Set cookie adds a set cookie header to the provided response writer's headers, right? So it adds the set cookie header. Cool. To the response writer's header. The provided cookie must have a valid name. Invalid cookies may be silently dropped. So you got to make sure you have a name for your cookie. It needs to be a pointer to a cookie, and that cookie is right there, right? And so we just create a struct, and that's all we've done here. Set cookie, and we give it the response writer, and then it needs to be from package HTTP, type cookie, and then we set, it's just a struct. And this is a composite literal. We have the type, and then curly braces, and then we populate the fields with values, right? And this is good practice to name your fields. Name your fields. That's best practice in coding. That's idiomatic. That's good for working in teams. That's best practice. Name your fields like that. A lot of times you'll see me not do that. And the best practice, I'm just saying it here, is to name them. And then this ampersand right here means I don't want to pass this value. I want to just pass the address in memory where that value is stored. And that's called a pointer. And we haven't talked about pointers in this class, but that's what that meant in the documentation here, where it said in the documentation it wants a pointer to a cookie. Right? Func set cookie from package nethttp wants a pointer to a cookie. So that little asterisk says this is the address where a value is stored. So the way computers work is it's like they store values. Computers store values, and they have a massive mail room with a bunch of mailboxes, each with their own address, and this is memory, and they just put things in those slots, and those slots all have an address, right? Just like you might go to the post office box, and you have post office box 128 at the Maroa post office station, right? And if you want to see what's in 128, you could go open it up. 128 is the address where your stuff would be stored. Here, I have a value stored in some address. Instead of passing around the value, I could just pass around the address. And that's saying, give me the address. Give me the pointer. It's pointing to what's stored there. It's kind of like, hey, if I say, go get the stuff in mailbox 128, you just know you go to 128. You know the memory address. And then you pull out whatever's in there. If I say, go get, and I list out all the values of everything that's in there, I don't know. It's different, right? It's the values. And this is just the address. Does that make sense? So when you see the pointer, that is part of the type. That is a totally different type than a cookie. It's an address. It's a pointer to a cookie, okay? And the asterisk is the type. Sometimes you'll see that asterisk again, and it's an operator, and it's dereferencing an address. And you can see this in my introduction to Go programming. You want to have a little bit of a, there's probably people that are confused, so let's have a little bit of a foray into this and go to the Golang playground. And so I can declare a variable, x : equals 42. And I could print out x. And I could also print out the address where x is stored. What I do to take an address. What is the operator? What is the operator for taking the address? Ampersand. There's the address in memory where that value is stored. That's pretty cool. If I want to assign that address to something, I could say var y is a pointer to an int. That is I'm declaring that y is of type pointer to an int. That's its type. Just like I could say var z is an int. I'm declaring z is of type int. And I could assign to z, 73. And I could assign to y is equal to ampersand x. The address where an int is stored, a pointer to an int. And then I could print out func.println, and I put 7 there. That needs to be y. Func.println y, z. So this will print out 73, because z is an int, and I've stored an int there. This will print out a memory address. Right? Here I printed that memory address just right there, which gave me this. And then here I said y is a pointer to an int. Now give me the memory address. Give me the memory address where that value x is stored. And so it gave me that again, and then I printed it here. Same memory address. Right? I cannot do this. Z is equal to ampersand X. I can't do that. My program is going to blow up. And it's going to say mismatch types. Cannot use ampersand X type pointer to an int as type int in an assignment. Right? This is wanting a value of type int. I tried to assign it a value pointer to an int. Pointer to an int is a type. Int is a type. Two different types. Okay? And this is statically typed, a statically typed language, meaning the compiler, it's static. It doesn't change. Static. Right? You say that y is of type pointer to an int, static. Static, static, doesn't change, static. Y is always pointer to an int. Dynamic, JavaScript, yeah, whatever, dude. Make it a string, cool. That's JavaScript, that's dynamic. Y can be a string, great, I like it. And then you get all kinds of errors. You're like, what the hell's going on? The compiler is going to check, is your shit in line when it's static. And you like that. You want that compiler. It's your friend. Static is awesome because it prevents a lot of like mysterious errors that you get with crappy dynamic stuff. So last thing I'm going to show you, we're going to get rid of this one here. I just want to show you how the static type thing, and we're getting rid of that one. So this should all work again. And you can see here, I'll just get rid of that, same deal, right? Getting the address. But watch this. Kapow! Nice. So this, right? Y stores a pointer to an int. So I got the address of X, which is an int, and that's going to store in Y. Fine. I print out that address, and then I say with Y, dereference this address. Give me the value which is in this address. This asterisk right here and this asterisk right here, two different things. This one is part of the type. That is like one phrase there, just like, HOME is all one thing. HOME, home, or, FOOT, like F and O and O and T are all together. F is not separate from OOT when you see the word foot. Right? This asterisk right here is not separate from int. This is all one thing that you read, pointer to an int. That's a type. Just like this is a type. Right? Just like an int is a type. Here, this is an operator like plus is an operator. Like division, like subtraction is an operator. This operator is saying, look, I know this is an address. Give me the value there. That's what that operator does. Okay? So this is how you take an address. This is how you define that you're storing a value that's going to store an address that's holding. You're going to have a value that you're going to have a memory address that stores a value of a certain type. Pointer to an int. It's a memory address storing an int. Right? And this says, give me the value in a memory address. When you have a memory address, give me the value. That's what that one does. You see the difference? So you just have to remember, ampersand gives me the address of some value. This will be the address where a value of a certain type is stored, where the value is an int, pointer to an int, pointer to a string, pointer to a whatever, right? And then this dereferences. When you have an address, this will give you the value that's in that address. That's cool. If you didn't know pointers, woo! I'm solid on that. Now, domain versus path. Got a little learning to do. But like, man, that Dr. Seuss quote, I don't know how now, but when I'm done, I will. It's cool. So we get the address because that's what this wanted. Right? We saw that up here. Set cookie wants a pointer to a cookie. And so down here we say, all right, well, I got an HTTP cookie. Here's the address. Cool, that's what that cookie wanted. And then I just write cookie written, check your browser. In Chrome, go to DevTools, Application, Cookies, and we could see it. And we could also go to this read one where we do request cookie, and we give it the name, my cookie. Exact same name is right there, my cookie. Say, give me that cookie, I want to read it. And then that gives me back, request cookie gives me back a pointer to a cookie. When I have a pointer to a cookie, I could print all that out. Most importantly, I could say c.value, right? And I could see the value of that cookie. So let's run this program and see some cookiness in action. Cookie written, check your browser. Sweet. So I'm going to open up Developer Tools, go to Application, Cookie, Application, and Cookies. And here I wrote a cookie, my cookie, some value. Plus at localhost I have some session for an application I was testing on localhost. So that's not going to do you any good. But I would never want to show this in a video. Like if I was at Reddit, hey, here's my bank account, here's my cookie value. Somebody might then be like, well, let me see if I create a cookie and set everything, all the attributes right, and go to that bank if it recognizes me as you. My cookie, some value. And clear all that out. Now they're gone. I'm going to reset it. Just got reset. And now I could go to read. And your cookie is my cookie, some value. My cookie equals some value. So that's what read did. Your cookie, there it is. So that's just the first get up and get going with cookies. I'm going to stop this video so it doesn't get too long. And I'm actually going to call this video, or at least include in this video, information about pointers and dereferencing and addresses, because I think that was covered well and people could use that help. And then right here, watch this, I do this and it runs my trailer.
This video is brought to you by Greater Commons. Greater
My
learning,
voice is still here, but there's a little clip
greater
that's
life.
running in the background.
Visit
Check us out,
at
greatercommons.com.
greatercommons.com.
It's going to be coolness. We're building it right now.